Statins. You know, there's a really good chance that you or someone you know takes one of these every single day. They're one of the most prescribed drugs on the entire planet, and they're all designed to do one thing: prevent heart attacks and strokes. But how they actually work and why they can sometimes cause that infamous muscle pain, well, that's a fascinating biochemical story that actually starts inside your own body.
So, let's pull back the curtain, shall we? We're going to trace the journey of a statin as it moves through your body's own chemical pathways. And by the end of this, I promise, you'll see exactly how this tiny pill can have such a massive effect, for better and sometimes for worse. All right, so before we can understand how to stop a factory, we first need to see how it runs, right? So our first stop is your body's own incredibly efficient cholesterol manufacturing plant.
That's right. Your body, and we're talking mostly about your liver here, is constantly making cholesterol. It's not just the bad guy we hear about all the time. You actually need it for building cells, making hormones, all kinds of important stuff. And this all happens on a very specific multi-step assembly line.
Okay, well, I know this looks super complicated, but don't worry about all the details. This is that assembly line we were just talking about. You only need to pay attention to one thing, this crucial little enzyme right here called HMG-CoA reductase. Just think of it as the master switch for the entire factory. If you can control this one switch, you control pretty much everything down the line.
So, we've got our factory, and we found the master switch. Now let's introduce the tool that was specifically designed to go in and flip that switch off, the statin. Statins are what scientists call HMG-CoA reductase inhibitors. It's a mouthful, I know. But in our factory analogy, it's simple. The statin is like the supervisor who walks onto the factory floor, goes directly to that master switch we talked about, and just shuts it down. And when HMG-CoA reductase gets blocked, the entire cholesterol assembly line just grinds to a halt.
And the effect? It is not subtle. It's immediate and it is powerful. By shutting down the body's internal production line, statins can slash your LDL. That's the low-density lipoprotein, the stuff we call bad cholesterol, by 30 to 60%. I mean, that is a massive impact, and it's exactly why these drugs are so incredibly good at reducing cardiovascular risk.
But, and there's often a but, isn't there? It's not always a perfectly smooth ride. And this brings us to the most talked about side effect of statins. And for a long time, it was a bit of a medical mystery: the muscle pain.
I mean, it's the big question, right? If this drug is supposed to be working in the liver to lower cholesterol, why on earth are people feeling it in their leg muscles or their back? Well, the answer takes us right back to that factory assembly line.
You see, it turns out that assembly line has a few crucial off-ramps and branch lines. And shutting down that main HMG-CoA reductase machine is like closing the main highway. It doesn't just stop the main flow of traffic, it also stops the production of other vital molecules that were supposed to take those exits. This is the collateral damage, and it's where the trouble really starts.
And the key to solving this entire muscle pain mystery comes down to one molecule. A molecule you've probably even seen sold as a supplement in health food stores, coenzyme Q10. So this diagram really shows us that whole chain reaction. You see the statin comes in at the top, and yeah, it successfully blocks cholesterol. But look what else gets blocked right alongside it, Q10. And that reduction, that has major downstream consequences, right where we feel it, in our muscles.
Let's just break this down. First, the statin blocks the pathway. Simple enough. Second, because of that, CoQ10 production plummets. Now here's why that matters. Third, our muscle cells are packed with mitochondria. They're the tiny powerhouses that generate all our energy, and they absolutely need CoQ10 to do their job. So fourth, without enough CoQ10, the mitochondria can't produce enough energy. This creates a muscle energy crisis, which can lead to those aches, pains, and even damage.
This whole collection of issues has a name: statin-associated muscle symptoms, or SAMS for short. For most people who experience it, it's myalgia, which is basically just the medical term for muscle aches and pains. Less commonly, it can cause myopathy, which is actual muscle weakness, and in very, very rare cases, a severe condition called rhabdomyolysis, where muscle tissue actually starts to break down.
Okay, so now we understand the amazing benefit and the potential side effect. So how do doctors and patients actually make a decision? Well, it all comes down to weighing the risks and the rewards for each and every individual. This quote from the research really gets to the heart of the matter. It might sound a little dense, but the key words you need to hear are absolute benefit and absolute risk. Let's break down exactly what that means.
So, on the one hand, you have relative risk. Statins reduce the risk of a heart attack by about 30% for almost everyone who takes them. That sounds great. But on the right is what really matters, your absolute benefit. Think of it this way. If your personal risk of having a heart attack in the next 10 years is only, say, 1%, then a 30% reduction of that tiny number is still a tiny benefit. But if your risk is 30% to begin with, that same 30% reduction is now a massive, potentially life-saving benefit. See the difference?
And really, that's the whole ballgame right there. Statins are incredibly powerful drugs that have, without a doubt, saved countless lives. But the decision to take one is always a personal calculation. It's a conversation between you and your doctor, weighing that profound benefit of protecting your heart against the potential risk to your muscles.
And all of this leaves us with a really fascinating question for the future. Now that we understand this collateral damage, can we design new therapies that are more precise, that can shut down cholesterol production without hitting these other vital pathways? It's just a powerful reminder that even with some of our most common drugs, the story of discovery is never, ever truly over.